All right, so 1.6 has like an A, B, C, D, and an E, I think. It's lots of different types of equations. So we'll cover some in video 1 and some in video 2. All right, so the first one is a polynomial equation. So these are examples of polynomial equations. Remember that the general form is everything on one side equal to 0. You have to have your powers in descending order. The degree is the highest degree of any term. So if you have everything in order, it's that first term's exponent. And the degree is really important to you because it tells you how many solutions. So like this is a degree of 3. We should get 3 answers. Now, sometimes remember they're imaginary. Sometimes they're going to repeat if you remember what you learned in Algebra 2. But you should get 3 answers, even if the same one is there more than once. All right, so we're going to solve polynomials by factoring. That's the only polynomial solving that we're doing. So remember all that P and Q stuff and other things that you learned, long division, synthetic division. We're not doing that. We're just by factoring. So we need it equal to 0. And then we're going to factor. So generally, we're going to have to factor with grouping because we have 4 terms. Or you're going to have to do some kind of like factoring into 2 binomials. We'll get to that. These first 2 are going to be factored by grouping because there's 4 terms. So take the first 2, pull out what they have in common. Take the back 2, pull out what they have in common. At this stage, those parentheses should match, so pull that out as your common factor. And then you're solving by factoring, so you can keep factoring until you can't factor anymore, or you can stop here and solve because you know how to handle this. It's really up to you. So we have x minus 11 is equal to 0. I know how to solve a quadratic, so I can just set this equal to 0. So we get that x is 11. We get that x is, once we take the square root of both sides, we get that x is plus or minus 2. So positive 2, negative 2, and 11. Those are our 3 solutions. All right, so the next one, we need it equal to 0. So subtract x, subtract 2. My husband is talking on the phone in the other room and he's loud. If you can hear him, I apologize. All right, so group the front 2. What do they have in common? First of all, I need to make sure that I write clearly because this is 5x to the third and this is 10x squared. All right, so we can take out what 5x squared and have x plus 2. If you look at those back 2, all they have in common is that they're negative. So take out a negative 1 and you have x plus 2. So then you have x plus 2 as matching parentheses, 5x squared minus 1. Now this one you can't factor, excuse me, anymore. So just set your factors equal to 0 and solve. So this guy's easy. You get x is negative 2. Here we're going to add 1. We get 5x squared is equal to 1. Divide by 5. We get x squared is equal to 1/5. Let me see if I can make some more space. All right, so then we have to square root both sides. So we get x is equal to plus or minus 1, the square root of 1 is 1, over root 5. And then remember, we can't leave root 5 in the denominator, so we're going to rationalize, multiply the numerator and denominator by that root 5. So you end up with plus or minus the square root of 5 over the square root of 25, which is just 5. So you get negative 2, and then you get positive root 5 over 5 and negative root 5 over 5. All right, so number 3, first step is we need everybody on the same side. So let's move the 11x squared over here. All right, so looking at this, I see a GCF of x. And then you would love for this to factor, but I don't think that it does. There's no way to multiply to get 3 and add to get 11. So we get that x is 0, and we get x squared minus 11x plus 3 is 0. And now we're left with, if it doesn't factor, how do we solve it? Well, we have the quadratic formula, and we have completing the square. I don't want to complete the square with that being an 11. So we'll quadratic formula. A is 1, B is negative 11, C is 3. So remember your quadratic formula. So we would have a negative 11, so positive 11. And then negative 11 squared and minus 4 times 1 times 3. So we have 11 plus or minus whatever that works out to be all over 2. What is that? 121 plus 12. So 133. And then I believe that's all we have because I don't think 133 will simplify. I can't think of a perfect square that will go in to 133. All right, so number 4, let's see. We can just take out a 5y squared. So we'd have y squared minus 9. And then we can say 5y squared equals 0, y squared minus 9 equals 0. So divide by 5, and y squared is still 0. Take the square root, and y is 0. Now that's a repeated 0 because technically, like, I could break this up into y equals 0, y equals 0. So keep that in mind. That's technically 2 of our answers. Y squared, add the 9, y squared equals 9. Take the square root of both sides, and you get plus or minus 3. So that gives us 4 distinct answers. Up here, make sure we don't forget to box the 0. All right, so these they're actually different than the others, so I don't know why I called them U-try problems. We're equal to 0, so we're going to try to factor. We've got 3 terms. So we're going to factor this the same way we factor a quadratic because it's kind of what it looks like. We can do x squared times x squared to get x to the 4th, and then we need a negative 7 and a positive 1 to make the other numbers work. That multiplies to get negative 7, adds to get negative 6. So then set those equal to 0 using the 0 product principle or property. So we will get that we have plus or minus root 7. Here we're going to subtract 1, take the square roots, and you get plus or minus I. So the square root of negative 1 is I. All right, here, if you try to just like use the square root property, you're going to lose some answers. So you're going to need to factor this. This is a difference of squares. It'll be a squared plus 9, a squared minus 9. Using that difference of squares pattern that we learned previously. The square root of this is a squared. Square root of this is 9. Add 1, subtract 1. So then if you set each of those equal to 0, you're going to get 4 answers. You'll have that this one ends up being plus or minus 3i, and then this one just ends up being plus or minus 3. My handwriting is getting super sloppy. I apologize. All right, you're going to need to show all of that work on a test. In Math Excel, if you can think that it does this and then you fourth root it and you get 3, like plus or minus 3, you got to remember that there's actually some imaginary ones in there too, so add those as well. But all of this is necessary on a test. All right, so 1.6b, we're solving radical equations. So radical equations are when there's a radical, a square root, a cube root, fourth root, whatever. You will see square roots on your test. That is all. I'm pretty sure that's all that they put in Math Excel as well. All right, so when you're solving a radical equation, you want to arrange the terms so that there's one radical by itself. If you can't do that, then you need one on each side. You can't work it when there's 2 on one side. So either one by itself or one on each side. Once you have that accomplished, then you can square both sides or cube it or whatever. But with the square root, you're going to square it. And then you solve whatever equation you get out of that. You have to check your answers though, because you do get extraneous solutions in square root sometimes. Sometimes you get answers that aren't actually there. All right, so an extraneous solution is a solution that you get when you raise both sides to a power, an even power, so a square root, or when you square it for a square root. And then you're going to have to check your answers to make sure you get rid of any that aren't really good. All right, so here we only have a single square root, so we're going to move the 3 to the other side. And then we're going to square this. And then we're going to square this. Remember, write this down twice and multiply it out. It should be x squared minus 3x, so minus 6x, and then plus 9. All right, so then we're going to get everything on the same side. And then it's a quadratic, so we're going to hope that it will factor. I believe it will. X minus 1, x minus 6. All right, so then before we box those, we need to go back and check. And again, that's something that they're going to want to see that you did on your test. So be in the habit of writing it down. So if we're checking for x equals 1, plug in 1 for your x's. So we get 2 plus 3 is equal to 1. That's no good. So he's no good. Then we check it for the 6. Occasionally, both of them will work. Usually only one will, but you still need to show that you checked both. All right, number 8, they have your radical isolated already. So if we just square both sides, we're going to get x is equal to, this will be x squared. We'll get minus 6x twice, so minus 12x, and then plus 36. Subtract this x over here. So we get x minus 9, x minus 4. Yeah. So x minus 9 equals 0 gives us 9 as an answer. I forgot to show over here this step. Make sure that you're always showing all of these little nitpicky steps. And then also remember you got to show on a square root, make a mental note, a big old note in your notes that you have to check the answers to a square root problem. So 9 works here. 4 does not. All right, so making them a little more complicated. So remember we have to cross multiply if you have a fraction equal to a fraction. So we'll have the square root of this equals 5x. So then we can square both sides. We'll have negative 11x plus 1 is equal to 25x squared. Add the 11x and subtract the 1. So 0, and then 25x squared plus 11x minus 1. That is not going to factor. So quadratic formula. Remember that you're going to have to show the formula, like write the formula down on a test. All right, so let's see. Negative 11 plus or minus something over 50. Also pay attention because on questions like this in Math Excel, they may want decimal answers. Make sure you're reading and knowing what they're asking of you. All right, so 11 squared minus 4 times 25 times negative 1 is 221, which still doesn't simplify. So for an exact answer, this is it, but that's 2 different answers. Or we can get a couple of decimal points for it if they want decimals. You also have to make sure that they're going to work. So just talking this through, I'm not going to write all of this down. There's nothing like this on a test. You just got to get through the Math Excel one. If I do this, the square root of 221 is going to be close to 15. Yeah, it's like 14.8. So if we add, we're going to get a positive number. If we subtract, we're going to get a negative. And that's all I'm going to think about. So if I put a positive number in here, we're going to get a bigger negative and then add 1, and it's still going to be negative. You can't take the square root of a negative. So it's not going to work out. If I put a negative number here, then we're going to get a positive, but then it's negative over here. So it's still not necessarily gonna work out. So I'm pretty sure this one works out to be no solution when you do that one on Math Excel. All right, so number 10, remember we need a square root on each side when there's 2 of them. And then we have to square both sides. Remember, you're squaring this whole side. So x minus 5. And then remember that this is doing this times this, which I haven't been showing on the other ones because they were a little easier to follow. So we're going to get 25 minus 5 root x minus another 5 root x, and then plus the square root of x squared. So simplifying just a little, I can combine these and have negative 10 root x. The square root of x squared is just x. All right, so I still have a square root. So now I've got to work on getting everything moved over here. so that that square root is by itself, because I'm going to have to square both sides again. The good news is those cancel. So we get negative 30 equals negative 10 square root x. And I can divide by negative 10 and have 3 is equal to the square root of x. So then we're going to square both sides to get x by itself, and then we're just equal to 9. All right, so I'm pretty sure this works when I put a box on it, but remember you have to check. I didn't show the check on number 9 because it was really gross, but we will show it on here. I just put 2 equal signs in there. One of those is a plus sign. All right, so this is the square root of 4 plus 3 is 5. So 2 plus 3 is 5. So yes. All right, so that's solving square root equations. All right, so equations with rational exponents. These are kind of similar to the square root ones, but not really. This is information you have to remember. Remember that a power to a power, you're multiplying your exponents. Remember that a fraction turns into a radical. Fraction exponent turns into a radical. Remember, if I multiply reciprocals, I get 1. And if you take an even root, you need a plus or minus on your answer. All right, so like for this particular problem, the reason these are important is I need this idea to start with. If I raise this to the 4/3 power, we're going to multiply those exponents. And if I multiply reciprocals, I just get 1. So by raising to the reciprocal power, I can get rid of a fraction exponent. Well, on the other side, when I raise it to the 4/3, I need to remember that that means to do this. So that's going to be the cube root of 125 to the 4th. So 5 to the 4th. So what is 5 to the 4th? I think 625, am I right? Yes. All right, so that's really all there is to it. But you know, they aren't always going to be quite that straightforward. All right, so this first one is though. So we're going to raise both sides to the reciprocal, so the 2/7. So we get x is equal to 3 to the 2/7. MathXL may let you write it in like that. They may want you to write it in as a 7th root of 3 squared or the 7th root of 9, but there's nothing you can do beyond that. All right, so again, if they want fraction exponents, rational exponents, type this in. If they want it in radical form, type this in. Make sure you read the fine print. All right, number 12, we're going to add 4. And then we're going to raise both sides to the negative 3 power. So that'll make this just x. And then this will make this 1 over 9 to the 3rd, or 1 over 729. Almost said that, but I thought I was wrong. So I checked it with my calculator. All right, so number 13. I took for granted up here that you remember this. Remember negative exponents, we have to send them to the bottom. That was a rule we learned in the very first lesson in this class. All right, so we're going to raise to the reciprocal, so the 3/2. So x minus 4 is going to be equal to the square root of 16 to the 3rd. I'm taking an even root, so I'm going to do a plus or minus. So we'll get plus or minus 4 to the 3rd. So this is 64 plus or minus 64. So I'm going to go ahead and just split it and do one for positive 64, one for negative 64. And then add 4 and get 68. And then add 4 and get negative 16. All right, so switch colors in case they start running together down here. we're going to raise this to the fourth. So 10 squared minus 9 would be equal to x to the fourth. So since we have lots of terms and exponents, we're going to get it all on one side equal to 0. And we're going to hope that it factors. So let's see. We can do x squared and x squared. And then -1, -none. So set each of those equal to 0 using that zero product property, zero product principle. I've always called it the zero product property in every other book that I've ever taught out of. And then this one called it the zero product principle, so whichever. All right, so set them equal to 0, move the constant over, take the square root. Don't forget your plus or minus. So we get plus or minus 1 and plus or minus 3. And I think that's all for day 1. Yes.